The purpose of this video is to provide an introduction to the JetXpert interface. Over on the left-hand side of the screen is the image buffer. This is where images taken using the JetXpert camera will appear. On the right-hand side of the screen is the user interface. The first thing I want to do is go ahead and start jetting using my print controller. Now that I'm jetting, I'm ready to start the strobe. The mode we're looking at now is called variable delay. In this mode, the software starts at a starting delay value, in this case 30 microseconds, and goes to an ending delay value, in this case 180 microseconds, using a step size, in this case of 10 microseconds. This allows you to see how the drop evolves as it's being ejected from the nozzles. The second mode we'll look at is called single pulse. This is using a fixed delay of 190 microseconds. If I want to look at the drop at a different point in time, I simply change this value. The third mode we'll look at is called double strobe. This is different from single strobe and variable delay in that double strobe is usually used for measurement, whereas single strobe and variable delay are usually used for drop visualization. When I switch to double strobe, I'll have twice as much light as before. This is because the LED is pulsing twice for each drop instead of once, so I see each drop twice on the screen. Since I have twice as much light, I'll want to turn down the pulse width. The pulse width is the amount of time that the LED is on when it strobes. For measurement, I want to choose a pulse width value that's as low as possible while still showing clear contrast between the drop and the background. If I choose too large of a value and I have a very fast moving drop, it's possible that I'll see a little bit of blur around the edges. I also want to change my delay 1 so that the drop has enough time to fully form into a sphere. Finally, I'll want to make sure that the drops are appearing inside this box labeled auto drops. If they're not, I can simply move the head in order to put them in the box. Alternately, I can move the box by clicking over to the Basic tab and clicking the arrows. I can also move the box by stopping the strobe and dragging the sides of the box. If I drag the corners of the box will be resized. Once the drops appear in the box, with sufficient contrast between the drops and the background, in focus, and I've calibrated, I'm ready to make measurements. I can make a measurement simply by clicking Analyze Now. A measurement report appears. This will show the radius, volume, trajectory, and velocity of the drop. In this case, I have a drop with a volume of 27.79 picoliters, a trajectory of 89.9 degrees, and a velocity of 2.65 meters per second. On the bottom, statistics are collected over time with multiple drops. The mean, standard deviation, minimum, and maximum of each of those measurements is shown. If I want to make multiple measurements, I simply click Analyze Multiple. Now the software continues to run and collects measurements. The statistics are updated as it goes. Once I'm finished, I hit Stop Strobe. Each individual run is saved in whatever file I designate here, next to Data File Name. In this case, I've chosen drops.xls. This file is located in the Data and Reports directory. Let's open that drop.xls file and take a look. I have a row for each individual measurement I've made, which shows the average radius, volume, trajectory, and velocity. At this point, I can run whatever statistics I like. If I change inks or change waveforms and want to make some new measurements, it's likely I'll want to change this name. That way I can differentiate one data set from another. Another way to differentiate data sets is by using experiment ID and comments. These appear in the spreadsheet as well, under the first column, experiment ID, and the last column, comments. I can also collect videos. For example, suppose I want to save a video of the drop formation in order to embed it in a PowerPoint presentation. I simply hit Start Recording. Once I have the recording I want, I hit Stop Recording. The software then collects all of the individual images and saves them in a directory, and uses those images to create an AVI video file. Once I see the message, Movie Completed, the movie is ready to use. It's found in the directory labeled Saved Images. Video directories have their own directory that's time-stamped. Each individual frame is here in TIFF format, as is the AVI file. I can simply drag this AVI file into a PowerPoint presentation. Alternately, I can also save individual images simply by clicking Save Images. This image will appear in the same directory, Saved Images, with a timestamp. Once I've done a great deal of analysis, and I've switched inks or switched waveforms, I may not want the new measurements to be included in the old statistics. In order to zero out the statistics, I simply hit Zero Statistics. Finally, it is possible to jet at such a high frequency that there simply isn't room to use a double strobe. That is, if the drops appear so frequently on the screen that the second image of one drop overlaps with the first image of another drop, it's important to use this mode here. Use frequency for velocity measurements. In this mode, instead of measuring between two different images of the same drop as you would in double strobe, you measure using single strobe between two different drops. Simply enter the current frequency that you're jetting at, and the calculation will be done as before. Remember, what's needed to calculate velocity and trajectory is to know the distance that the drop travels over a certain period of time. This works with double strobe because we know the time delay between the images of the drops, and we've calibrated so we know the distance in real-world units. Works just as well this way because if you've entered the jetting frequency, we know the time between the drops, and as before, since we've calibrated, we know the distance. Most people do not need this setting, but it's important to know if you do need it.